Jai Hind everyone. Let's continue with chapter 5 of NCERT class 11 physical geography, that is geomorphic processes. So in with this video we are starting chapter 5. Let's go. So the chapter name is geomorphic processes. Let's start from here. The Earth's crust is dynamic. You are well aware that it has moved and moves vertically and horizontally. Of course, it moved a bit faster in the past than the rate at which it is moving now. The differences in the internal forces operating from within the Earth, which built up the crust, have been responsible for the variations in the outer surface of the crust. So, what is the reason given here? But what is the question first? Why is the surface of the Earth uneven? So, further the answer is the differences in the internal forces operating from within the Earth which build up the crust have been responsible for the variations in the outer surface of the crust. So this is the reason why the surface of the Earth is uneven. The Earth's surface is being continuously subjected to external forces, including basically by energy. So the Earth's surface is subjected to sunlight also. Of course, the internal sources are still active through with different intensities. That means the Earth's surface is being continuously subjected to by external forces originating from within the Earth's atmosphere and by internal forces from within the Earth. So there were names that have been given to internal and external forces also. The external forces are called exogenic, whereas the internal forces are known as endogenic forces. The actions of exogenic forces results in wearing down, which is called degradation of relief, elevations, filling up. Like that means aggradation of basins and phenomena. So if there is any higher point, that will be degraded, and if there is any depredation, the debris that has been carried from the degradation of relief will be taken and filled up in the depressions on the Earth's surface. The phenomenon of wearing down of relief variations on the surface of the Earth through the erosion is called gradation. So what is gradation? Wearing down of relief variations of the surface of the Earth through erosion is known as gradation. The endogenic forces continuously elevate or build up parts of the Earth's surface. So the endogenic forces work in opposite to the exogenic processes. And hence, the exogenic forces fail to even out the relief variations on the surface of the Earth. So, although the exogenic forces are acting in gradation, why is in the Earth surface uneven? Because it is the opposite work of the endogenic forces. So, variations remain as long as the opposing actions of exogenic and endogenic forces continue. Therefore, what it is telling, the variation or uneven surface of the Earth continue to be until the opposite actions of exogenic and endogenic forces continue. In general terms, the endogenic forces are mainly land building forces and the exogenic forces are mainly land wearing forces. So other name for endogenic is land building forces and the other name for exogenic processes are land wearing processes. The surface of the Earth is sensitive. Humans depend on it for their sustenance and have been using it extensively and intensively. So it is essential to understand its nature in order to use it effectively without disturbing its balance and diminishing its potential for the future. So the sustainable use of the Earth is essential not only for the welfare of the Earth but also for the humans. Almost all organisms contribute to sustain the Earth's environment. However, humans have caused extensive damage to the environment through overuse of resources. Use we must, but must also leave its potential enough to sustain life through the future. Most of the surface of the Earth had and has been shaped over very long periods of time. And because of its use and misuse by humans, its potential is being diminished at a fast rate. If the processes which shaped and are shaping the surface of the Earth into varieties of forms and the nature of materials of which it is composed of are understood, precautions can be taken to minimize the detrimental effects of human use and to preserve it for posterity. So what is it? What is it telling? So if we know what are the things that Earth is composed of, and if we know what are the processes that are currently shaping the surface of the Earth, we can take precautions accordingly to minimize the harmful effects of human use or the detrimental effects of human use. Now we'll get into the topic, that is geomorphic processes. You would like to know the meaning of geomorphic processes. The endogenic and exogenic processes causing physical stresses and chemical actions on the earth materials and bringing about changes in the configuration of the surface of the earth are known as geomorphic processes. So what are geomorphic processes? The processes either exogenic or endogenic that can bring change in the configuration of earth's surface by either physical action or chemical action. So then they are called geomorphic processes. Diastrophism and volcanism are endogenic geomorphic processes. So what are the endogenic geomorphic processes? These are diastromism and volcanism. These have already been discussed in brief in the preceding unit. Weathering, mass wasting, erosion, and deposition are exogenic geomorphic processes. So what are the exogenic geomorphic processes? These are weathering, mass wasting, erosion, and deposition. So we learned that exogenic processes are land wearing process. Then why is deposition included in exogenic geomorphic processes? Because after any gradation, the last step will be deposition. So if we degrade any material, the debris will be carried away, and when the air or the agent that is carrying the material loses energy, it will get deposited in some place. The last step of erosion will be deposition. So that's why deposition is included in exogenic geomorphic processes. Any exogenic element of nature, which is water, ice, wind, etc., capable of acquiring and transporting earth materials, can be called as geomorphic agent. So what is a geomorphic agent? Which is capable of transporting earth materials. That can be anything like water, ice, wind, etc. When these elements of nature become mobile due to gradients, they remove the materials, transport them over slopes, and deposit them at lower level. So what is the process? From the higher altitude, these will be taken off and they will be traveled through the slopes and deposit them at lower level. This is the process in any geomorphic process. The geomorphic processes and geomorphic agents, especially exogenic, unless stated separately, are one and the same. So what is except in a special condition, the geomorphic processes and geomorphic agents are one and the same. A process is a force applied on earth affecting earth materials affecting the same. So what is a process? A process means a force which is applied on a surface material or earth material. And what does it affect? It affects the same earth material. An agent is a mobile medium. So mobile mediums that can be moved. So that agent can be anything like running water, moving ice masses, like next wind, waves, currents, etc., which removes, transports, and deposits earth material. So these are all agents. Agent should be a mobile medium. Running water, groundwater, glaciers, wind, waves, and currents can also be called geomorphic agents. Why? Because they are capable of removing, transporting, and depositing earth materials. Gravity, besides being a directional force activating all downslope movements of matter, also causes stress on the Earth's material. So there are dual functions of gravity. First, it activates all downslope movements, and also it causes stress on the Earth materials. Indirect gravitational stresses activate wave and tide induced currents and winds. So how does the gravitational stress work? It is indirect, and it activates wave and tide induced current and winds. Without gravity and gradients, there would be no mobility, hence no erosion. So if there isn't no gravity, there is no gradient, there isn't no mobility, and then no erosion. So gravitational stresses are as important as the geomorphic processes. Gravity is the force that is keeping us in contact with the surface, and it is the force that switches on the movement of all surface material on Earth. All the movements either within the earth or on the surface of the earth occur due to gradients, that is from higher levels to lower levels or from higher pressure to lower pressure. So everything that is related to geomorphic process is dependent on gradient, that is from higher place to lower place or from higher pressure to lower pressure. Now what are endogenic processes? Under geomorphic processes, there are two, that is endogenic, exogenic, which are responsible for change in configuration of Earth's surface. Now we'll get into details of the endogenic processes. The energy emanating from within Earth is the main force behind endogenic geomorphic processes. So which is responsible for this? The energy emanating from within the Earth. This energy is mostly generated by radioactivity, rotational and tidal friction, and also primordial heat from the origin of the earth. So from which sources the energy is being emanating? That is from radioactivity, rotational and tidal friction, and also primordial heat from the origin of the earth. This energy, due to geothermal gradients and heat flow from within, induces diastrophism and volcanism in the lithosphere. So what happens? This energy results in diastrophism and volcanism in the lithosphere. Due to the variations in geothermal gradients, heat flow from within, crustal thickness and strength, and action of endogenic forces are not uniform. Hence, the tectonically controlled original crusted surface is uneven. So, what it is telling, the geothermal gradients and heat flow within is not uniform. So, therefore, what happens? The tectonically controlled original crustal surface is uneven. Now, under endogenic, we have two, that is diastrophism and volcanism. Now, let's get into the details of diastrophism. First of all, what is diastrophism? All the processes that move, elevate, or build up the portions of Earth's crust come under diastrophism. So, under diastrophism, the Earth's crust will be built up. And they include two, that is orogenic and epirogenic. So, what is orogenic? Orogenic processes involve mountain building through severe folding and affecting long, narrow belts of the Earth's crust. So, under orogenic is also called mountain building processes. So, under orogenic processes, mountain building happens through severe folding. And the next one is we have epirogenic. Under epirogenic, uplift or warping of large parts of Earth's crust. So, epirogenic is just generally like continental building process. And then we have earthquakes. The third process under diastrophism is earthquakes, involving local relatively minor movements. And then we have plate tectonics. Under plate tectonics, involving horizontal movements of crustal plates. So what are all the processes that come under diastrophism? First is orogenic, second one epirogenic, third one earthquakes, and the fourth one is plate tectonics. In the process of orogeny, the crust is severely deformed into folds. So what happens under orogeny? The crust is severely folded. Due to epirogeny, there may be simple deformation. So the difference between orogeny and epirogeny is, under epirogeny there is simple deformation, but under orogeny there is severe folding. Orogeny is a mountain building process, whereas epirogeny is a continental building process. Through the processes of orogeny and epirogeny, earthquake and plate tectonics, there can be faulting and fracturing of the crust. So what happens due to these processes? There will be faulting and fracturing of the crust. All these processes cause pressure, volume, temperature changes within, which in turn induce metamorphism of rocks. So how does metamorphic rocks form? Due to PVT changes in either igneous rocks or sedimentary rocks. So these changes turn and induce metamorphism of rocks. So this is about diastrophism. Now let's get into details of the another endogenic process, that is volcanism. Volcanism includes the movement of molten magma onto or towards the Earth's surface. and also formation of many intrusive and extrusive volcanic forms. As studied in the previous chapter, we have extrusive that form on the surface of the earth, and whereas intrusive forms, they form inside the interior of the earth, like phaccolith, lapolith, laccolith, batholith. So these are all the intrusive and extrusive volcanic forms that are formed due to volcanism. And the next process we have is exogenic processes. The exogenic processes derive their energy from atmosphere. So under endogenic, the energy is derived from primordial heat, radioactivity, etc., etc. Whereas under the exogenic processes derive their energy from atmosphere, which is determined by ultimate energy from sun. So who is the ultimate energy source for exogenic processes? It is the energy from sun, and also the gradients created by tectonic factors. So two sources, that is sun and gradients created by tectonic factors. Gravitational force acts upon all earth materials having a sloping surface and tend to produce movement of matter in slope direction. So what happens? Due to the gravitational force, the material tends to travel from higher level to lower level in down slope direction. Force applied per unit area is called stress. So we all know what is stress. Force applied per unit area is called stress. But this stress is produced in a solid by either pushing or pulling. So how can be stress induced in a solid? By either pushing or pulling. And what happens when a stress is applied on a solid material? It induces deformation. So when stress is applied in a solid, it induces deformation. Forces acting along the face of earth materials are called shear stresses. So what happens when the force when the force is applied on the faces, along the faces of earth material? These are called shear stress. It is this stress that breaks rocks and other earth materials. So which stress breaks the rocks? That is shear stress. The shear stresses result in angular displacement or slippage. So what happens when it is applied? It results in angular displacement or slippage of the rocks. Next, besides the gravitational stress, earth materials become subjected to molecular stresses also. So there are two types, that is shear stress, that is gravitational stress, and also molecular stress that may be caused by number of factors, amongst which temperature changes, crystallization, and melting are the most common. So for molecular stresses, what are the factors? That is change in temperature, crystallization, and also melting. These are important. These are the factors for molecular stress. Chemical processes normally lead to loosening of bonds between grains, dissolving of soluble minerals, or cementing materials. So what happens? So if it is a rock and molecular stress is applied, it starts becoming smaller grains. So this is called molecular stress. But under shear stress, when the shear stress is applied, it tries to break into rocks like this. So there will be angular displacement. So this is the basic difference between shear stress and molecular stress. Thus, the basic reason that leads to weathering, mass movements, and erosion is development of stresses in the body of earth material. So what is the basic necessity for erosion, weathering, mass movement, and erosion? That is the development of stresses in the body, that can be either molecular stress or shear stress. Temperature and precipitation are the two important climatic elements that control various processes. So what are the things that control processes? That is temperature and precipitation. All the exogenic geomorphic processes are covered under a general term called denudation. So what is denudation? Under denudation, all the exogenic geomorphic processes were included. But what is denudation? The word denude means to strip off or to uncover. So denude means to uncover or strip off. And which processes come under denudation? Weathering, mass wasting or mass movement, erosion, transportation, these are all included in denudation. The flow chart gives the denudation processes and their respective driving forces. So if you see here, these are all the denudational processes. See, first one is weathering. This is the process. But what is the driving force for the occurrence of weathering? That is gravitational or molecular stress or chemical actions. So these are the factors that are responsible for the process of weathering. Whereas in mass movement, so what is the driving force? That is gravitational energy. Gravitational force is important for occurrence of mass movement. Whereas for weathering, either gravitational molecular stresses or chemical actions. And then we have erosion or transportation. So what is the important factor for erosion or transportation? It is kinetic energy. So for erosion and transportation, the movement of particles is needed from one place to another place. So when we only have kinetic energy, that movement is possible. So for erosion and transportation, kinetic energy is the main driving force. So these are all the processes and their driving factors. As there are different climatic regions owing to variations in thermal gradients created by latitudinal, seasonal, and land and water spread on the surface of the earth, the exogenic processes vary from region to region. So, the basic conclusion of this line is geomorphic like denudational processes vary from region to region. Why? Because of the conditions of latitudinal, seasonal, land, water that are spread on the surface of the earth. The density, type, and distribution of vegetation, which largely depend on precipitation and temperature, also exert influence indirectly on denudational processes. So, apart from this, the vegetation also, which is dependent on precipitation and temperature, also have indirect influence on denudational processes. Within different climatic regions, there may be local variations of the effects of different climatic elements due to altitudinal differences, aspect variations, and the variation in the amount of insolation received by north and south facing slopes as compared to east and west facing slopes. So under vegetation also, different climatic elements such as variations in altitude and the amount of insulation received by the slopes, these are also important and because they have indirect influence on the denudational processes. Further, due to differences in wind velocities and directions and amount and kind of precipitation, its intensity, the relation between precipitation and evaporation, daily range of temperature, freezing and thawing frequency, depth of frost penetration, the geomorphic processes vary within any climatic regions. So these are all the processes that can also have influence on the geomorphic processes. Climatic factors being equal. So if we assume that the climatic factors, their effect is equal, the intensity of action of exogenic geomorphic processes depend on the type and structure of rocks also. So if we consider that the climatic factors are being equal, then the type of rock on which the exogenic geomorphic process is being acted upon is also important. The term structure includes such aspect of rocks as folds, faults, orientation, inclination of beds, presence and absence of joints, bedding planes, hardness and softness of constituent minerals, chemical susceptibility of mineral constituents, the permeability and or impermeability, etc. These are also this characteristics in rocks also is important for action of denudational processes. Different types of rocks with the differences in their structure offer varying resistance to various geomorphic processes. So the characteristics of rocks define the resistance to various processes. A particular rock may be resistant to one process and non-resistant to another. And under varying climatic conditions, particular rocks may exhibit different degrees of resistance to geomorphic processes. Hence, they operate at differential rates and give rise to differences in topography. So what happened? under varying climatic conditions also, different degrees of resistance can be given by rocks, and it gives to differences in topography. The effects of most of the denudational processes are small and slow and may be imperceptible in a short time. So what happens in a short time, the effect of these processes may be slow and small, and it cannot be seen. Imperceptible means that cannot be noticed, but in the long run, it will affect the rock severely due to continued fatigue. So in the short run, it is imperceptible, but in the long run, it can severely affect the rocks. Finally, it boils down to one fact that the differences on the surface of the earth, though originally related to the crustal evolution, continue to exist in some form or the other due to differences in the type and structure of the earth materials, differences in geomorphic processes, and in their rates of operation. Some of the exogenic geomorphic processes have been dealt in here. So now under the denudational processes, we are going to learn each process in detail. The first one is weathering. So what is weathering? Weathering is action of elements of weather and climate over earth material. So what is the point here? The action of elements of weather over earth materials. There are a number of processes within weathering which act either individually or together to affect the earth materials in order to reduce them into a fragmental states. But how is weathering defined? Weathering is defined as mechanical disintegration and chemical decomposition of rocks through the actions of various elements of weather and climate. So weathering is called mechanical disintegration or chemical decomposition of rocks through the actions of what? Through the actions of various elements of weather and climate. Weathering is also called an on-site process, or it is an in situ process because there is no movement in weathering. The rocks are stable, the rocks are stationary, and they get disintegrated or they get decomposed. So that's why weathering is called in situ or on-site process. Weathering processes are conditioned by many complex geological, climatic, topographic, and vegetative factors. So these are all condition the weathering processes. Climatic is of particular importance. Not only weathering processes differ from climate to climate, but also the depth of the weathering mantle. So there are so many conditions on which the working of weathering depends. There are three major groups of weathering. So under weathering, we have three major groups. That is, first one, chemical weathering. Second one, physical or mechanical weathering. And the third one is biological weathering process. The first one is chemical weathering. What are the processes that come under chemical weathering? A group of weathering processes, that is solution. What comes under chemical weathering processes? That is solution. Second one, carbonation. Third, hydration. Fourth, oxidation and reduction. These are all the chemical processes that act on the rocks to decompose. So that's why it is called chemical weathering process. They act on the rocks to decompose, dissolve, or reduce them to a fine clastic state through chemical reactions by oxygen, surface and soil water, and other acids. So what are the things that are included in this? Oxygen, surface or soil water, and also acids. Water along with air. What constitutes air? Oxygen, carbon dioxide. Along with heat must be present to speed up all chemical reactions. So what are the mandatory things that should be present to speed up the chemical reaction? First is water, next air, and also heat. These are important to speed up the chemical reactions. Over and above the carbon dioxide present in the air, decomposition of plants and animals increases the quantity of carbon dioxide underground. These chemical reactions on various minerals are very much similar to the chemical reactions in a laboratory. So these are all the chemical weathering processes that are solution, hydration, carbonation, oxidation, and reduction. And the next category is Physical weathering process. Physical or mechanical weathering processes depend on some applied forces. So under chemical, it is based upon the chemical reactions, but under physical weathering process, it is dependent on the some applied forces. The applied forces could be gravitational force, such as overburden pressure or load or shearing stress. These are gravitational forces. And the next one is expansion forces due to temperature changes, crystal growth, or animal activity. So what are the expansion forces? That are temperature changes, which are due to temperature changes, crystal growth, or animal activity. Whereas water pressure. So how can water put pressure on the rocks? Either by wetting or drying cycles. Many of these forces are applied both at the surface and within different earth materials, leading to rock fracture. So what happens with this mechanical forces? There will be a fracture in the rock. Most of the physical and weathering processes are caused by thermal expansion and pressure release. So the continuous contraction and expansion of the rock leads to the mechanical disintegration of the rocks. So this is about physical weathering processes, under which we have gravitational force, expansion force, and also water pressure. And the next category is biological activity. So under biological activity, how is it contributed? Biological weathering is contribution to or removal of minerals and ions from the weathering environment and physical changes due to the growth of movement of organisms. So what happened? Due to the growth of organisms or movement of organisms, it leads to the weathering. Burrowing and wedging by organisms like earthworms, termites, rodents, etc. help in exposing the new surfaces to chemical attacks and assist in the penetration of moisture and air. Human beings, by disturbing vegetation, plowing and cultivating soils, also help in mixing, creating new contacts between air, water, minerals in the earth materials. Decaying plant and animal matter help in the production of humic, carbonic, and other acids, which enhance decay and solubility of some materials. And also, plant roots exert a tremendous pressure on the earth materials, mechanically breaking them apart. So, under biological activity, the actions by plants, animals, and also humans play a major role in the and contribute to the weathering of rocks. So these are all the categories under weathering, that is chemical weathering, physical weathering, and biological activity. Now there are some special effects of weathering. We'll see them. So what is the first special effect of weathering? That is exfoliation. The special effect of weathering is exfoliation. So what is this exfoliation? Exfoliation is a result, but not a process. So exfoliation is a result of weathering, but it is not a process of weathering. Flaking off of more or less curved sheets of shells from over rocks or bedrock result in smooth and rounded surfaces. So what happens? If it is a rock, due to the weathering, the outer layer gets removed from the inner layer of the rocks, and the rock will have a smooth inner layer surface that will be now exposed to the environment. The outer layer will be flaked off. This is called exfoliation. Exfoliation can occur due to expansion and contraction induced by temperature changes. So how does exfoliation occur? Due to temperature changes that result in expansion and contraction. Exfoliation domes and tores result due to unloading and thermal expansion respectively. So exfoliation domes will be resulted due to unloading, and tores will be resulted due to thermal expansion respectively. Now, what is the significance of weathering? Weathering processes are responsible for breaking down the rocks into smaller fragments and preparing the way for formation of not only regolith and soils, but also erosion and mass movement. So what happens when weathering takes place? There will be a possibility for not only formation of regolith soils, but also for erosion and mass movements. Biomes and biodiversity is basically a result of forests, and forests depend upon the depth of weathering mantles. So what happens? Weathering mantles are the condition for the forests. Erosion cannot be significant if the rocks are not weathered. So it is easier to transport smaller fragments rather than big rocks. So weathering is important for erosion. That means weathering aids mass wasting, erosion, reduction of relief, and changes in landforms are a consequence of erosion. So weathering helps mass movement, erosion. Weathering of rocks and deposits helps in the enrichment and concentration of certain valuable ores of iron, manganese, aluminum, etc. So weathering helps in enrichment and concentration of valuable ores, which are of great importance for the national economy. Weathering is an important process in the formation of soil. So with weathering, there will be fragmentation of rocks, which later makes for the formation of soil also. When rocks undergo weathering, some materials are removed. So it is basically the result of weathering is there will be erosion where the certain materials will be removed from the rocks through chemical or physical leaching by groundwater, and thereby concentration of remaining material increases. So what happens when certain material is removed by either physical or chemical action? The concentration of the other material increases. Without such a weathering taking place, the concentration of the same valuable material may not be sufficient and economically viable to exploit, process, and refine. This is what is called enrichment. So weathering helps in enrichment processes also. This will help in economically, because when there is when people are trying to mine the rocks, in mining also this enrichment processes will be economically profitable for uh, processes of mining also. So this is all about for this video, where we have covered endogenic processes, that is diastrophism and volcanism, and under exogenic denudational processes we have completely covered the process of weathering, and in the next video we'll cover the other processes. If you think the video is beneficial, please like and share the video. Let's meet in the next class. Jai Hind.